Back to flood irrigation. Okay, so what I've done here is I've poured off the excess water, and in doing so I've lost a bunch of the topsoil, and this water is, or this soil is completely saturated, and it appears to be relatively solid. Things aren't, you don't sink in it, okay, but it is completely saturated with water. Now, before I cover over this soil, then let's talk about what we see here. If we were to flood irrigate like this, then if the water has to run off or seep down into the soil. And if it stays like this, then we will have this problem here. And if we peel that back, you'll see there are no air pockets in that at all. Roots must have air pockets, and there must be open spaces in the soil in order for roots to grow and for our soil organisms to exist. And if you can go back and look at the videos on soil texture about that and see those firsthand. But when we flood irrigate like this, or over irrigate in any way, it doesn't matter if it's spray, drip, whatever, if you over irrigate, what you end up with is a waterlogged soil, in which case all of those air spaces that are needed for the roots get full of water, and it essentially suffocates the plants. So you can drown the plants or over irrigate and waterlog the soil. That happens all the time, all over the world. And then the only way to deal with it is to get rid of the water. And as I said, when there's only a couple ways for you to get rid of it. It's got to run off, in which case it's going to take a ton of topsoil and agrochemical with it. Or you have to sit here and let it evaporate, in which case the water's lost to the water cycle, and all the water that you put on this is gone, right? Or it has to percolate down if it can. Now sometimes it can't because there's been years and years and years of overwatering and the water table has risen up. That brings me to my next point. All right, so here I have taken that soil that was waterlogged and I've covered over it with some dry play sand, which has got some rock component to it, small rocks, and large coarse sand. Now that's just going to symbolize our topsoil that appears to be in relatively good shape and ready to plant plants in. But that's not the story because we've overwatered, we've over-irrigated. And what happens is, a couple of things. As soon as I go down, I hit waterlogged soil underneath it. So boom, there it is. You see that wet spot? And now there's standing water, okay? So the water table is too high. That causes a couple things. If it gets into the root zone where the roots grow, that top foot or 2 feet of soil, then that could suffocate or drown our plants. The other thing is this. As what is supposed to happen, and I talked about this in the first video, is that rain falls on the earth and a lot of the chemicals or the lot of compounds that are supposed to leach down, right? Phosphorus, salts in particular, are supposed to leach down and get piled up in that zone of deposition in that B or C horizon. Well, once we've over-irrigated and the water table is all the way up here, it won't continue to leach down in the water when it rains because it hits the other water and there it sits. And eventually what we get is those salts that is supposed to be going down into the deep subsoil, they're not in the deep subsoil, they're in the root zone because we've brought the water table up too high from over-irrigation. And that's what causes a problem called salinization or salting up the soil. And the salt concentration will kill the plants. And this also happens with phosphorus and things too that are supposed to be leaching down, but because they've been brought back up with that rising water table from over-irrigation, then the concentration becomes toxic for the plants. Once it's toxic for the plants, we can't grow food. Then we've got famine, we've got economic problems, things like that have come from bad agricultural techniques that lead to salinization and waterlogging.